Chapter 2: Conducting Experiments. Designing a scientific experiment. Before conducting an experiment, you must plan out exactly what is needed and how you are going to carry out the experiment. Starting points for designing an experiment are: 1. Observe something about which you are curious. 2. Construct a hypothesis. 3. Plan out the experiment to test the hypothesis. 4. Predict the outcome. 5. Conduct the experiment. 6. Record the results. 7. Repeat past experiments to see if you get the same results. An experiment requires a procedure and a list of materials and methods needed to conduct the experiment. You can have a controlled experiment by running the experiment more than once. First, without changing any factors, this experiment is called the control, and then a second time, changing only the factor you want to observe. In a controlled experiment, the factors that are not changed are called constants, and they don't affect the outcome of the experiment. Procedure: a step-by-step list of how to carry out the experiment. Control: a trial during which all of the variables are unchanged. A control is used as the standard comparison for an experiment. A variable is a factor that can alter your experiment's results. A controlled experiment allows you to test the influence of the variable. To test only one factor, all other factors in the experiment are held constant, unchanged. This ensures that the changes you observe are caused by the one variable that you changed. Different variables have different roles. An independent variable is the variable that you change in an experiment. A dependent variable is the variable that is influenced by the independent variable, the results of your experiment. Constants: all of the variables in an experiment that remain the same. Constantes: 1. Type of fish. 2. Tank size. 3. Water quality. 4. Water temperature. 5. Food type. 6. Locality and location. For example, goldfish experiment. Every couple of weeks, a teacher has to buy a new goldfish after the previous one has died. The class comes up with a hypothesis that the teacher's goldfish is not getting the right amount of food. They devise an experiment for the teacher to test this factor alone, holding all other variables: type of fish tank, size of fish tank, water quality, water temperature, food type, and location constant. In this experiment, the independent variable is the frequency with which the goldfish are fed. The dependent variable is the health of the fish after 2 weeks. Experiment control. Do ES that say 2.0 meters LOR 20 meters L. ISACCUR at EANDPRECISE. NOTACCUR. Collecting data. Good data is specific and detailed. They consist of both quantitative and qualitative observations. Measurements must be as accurate and precise as possible. Make sure that you measure things carefully. Have a notebook ready to record everything as you see it. Keep your notes neat so that they are easy to review. Unreliable or unreadable data are useless. Bad measurements: not accurate but precise, accurate but not precise, not accurate and not precise. Measurements should be both accurate and precise. Accurate: how close your measured value is to a standard or known value. Precise: how close two or more measured values are to one another. ACCURACY. P. Week 1, Week 2, Week 3. Plant A 2 cm 3 to 5 cm 6 cm. Plant B 1.5 cm 4 cm 7 cm. Bar graphs present data as bars of varying heights or lengths. This is an easy way to compare different variables. The taller, or longer, the bar, the larger the number. Presenting data. After collecting data, you can present it in many different, more quantitative ways. For example, tables present data in rows and columns. Because all of the numbers are close to each other, these are easy to read and compare. A table is a fast and easy way to record data during an experiment. Popularitisn, TEVERY thing G. Line graphs show the relationship between two variables. The independent variable is plotted on the x-axis, the horizontal line, and the dependent variable is on the y-axis, the vertical line. Each axis has a scale to show the intervals of the measurements. Scales are done in even increments, such as 1, 2, 3, 4 or 2, 4, 6, 8. Line graphs show continuous change over time. Circle graphs. Think of this as a pie chart. Each piece of data is represented by a slice of the pie. K etc. HUP. MUS tar RD. K etc. HUP plus MR. ONIONS. 8 CHOSEMUSTARD 6 CHOS. Plus MUSTARD 2. Analyzing data. Analyzing data is comparing and examining the information collected. This is something that all scientists need to do to determine the outcome of their experiment. Data is usually shown in the form of a diagram or graph. You compare the variables that are being tested against the ones that are being kept the same. It is important to compare your data accurately so that you can determine exactly what happened during your experiment. That way you will be able to repeat the experiment if needed. Which type of graph is best to show the data? Line graph. If your data has small changes in it, for example, an increase from 0.01 to 0.06, you can use a line graph. This format makes small differences more visible. Circle graph. If you want to show changes as part of a whole, use a circle graph. For example, if you need to record how much of an hour was spent on various tasks, this format would be good to use. Bar graph. If you are tracking large changes over a period of time, or groups of numbers, a bar graph might be best. For example, if you have different cars and you want to compare their top speeds against each other. Drawing conclusions. You have reached the end of your experiment. Did the results support your hypothesis? Why or why not? Even if your results did not support your hypothesis, you can still learn from them. It is important to explain in your conclusion why you think your hypothesis was wrong. Were there sources of experimental error, or did the procedure need to be changed? Sometimes, the conclusions aren't immediately obvious and you will have to infer, or use observations and facts to reach a conclusion about something you may not have directly witnessed. For example, if you want to find out what a Tyrannosaurus rex ate, you might observe the types of fossilized droppings that could be found near its fossils. If you see crushed bones, you might infer that the dinosaur ate smaller animals or other dinosaurs. When you need to infer, it can help to look at background information and do further research. 1. What are the two ways that data can be measured? 2. What graphs can be used to present data? 3. If the results from your experiment don't support your hypothesis, was the experiment a failure or a success? Explain your answer. 4. What is the difference between being accurate and being precise? 5. Why is it important to correctly analyze your data from an experiment? 6. You have collected data that shows large changes during a period of time. What type of graph would you use for this? 7. When would you use a line graph? 1. Data is either quantitative, in the form of specific measurements, or qualitative and based on the way something looks, feels, smells, or sounds. 2. 3 different graphs that are used to present data are line, bar, and circle graphs. 3. If the results from your experiment don't support your hypothesis, it does not necessarily mean that your experiment was a failure. Scientists can learn from every experiment. If the data doesn't support the hypothesis, then you can ask why and try to figure out any factors that may have affected the experiment. 4. Accuracy is determined using the closeness of the value that is measured to a standard or known value. Precision is determined through the closeness of 2 or more measured values to each other. 5. You need to correctly analyze your data so that you can compare your results to multiple experiments if needed. 6. A bar graph would be best for this data. 7. If your data shows small changes over time,